You know those gigantic, absolutely stunning LED screens you see at concerts or big events? Ever wonder how they get that picture so perfect? Well, it's not magic. It's a really careful process called screen mapping. And today, we're going to break down exactly how you, as a technician, can turn a chaotic mess of pixels into a flawless, breathtaking image. Look, every single LED tech has been there. You feel that pit in your stomach. You've spent hours, maybe days, rigging a massive wall. You finally hit the power switch, and instead of a beautiful picture, you get pixel chaos, a scrambled digital nightmare. But here's the good news. This almost never means your gear is broken. It's just a communication breakdown. The brain of the system, your video processor, just has no clue how you physically plugged everything together. And that's exactly why we have to start right here, in the real world, before you even think about launching any software. Seriously, most mapping errors happen because people ignore the physical reality of the build. So before you click a single mouse, it's time for a full-on physical audit. Think of this as your non-negotiable pre-flight checklist. First, is the structure itself solid enough for the weight and the wind? Remember, a lightweight aluminum cabinet is going to behave way differently than a heavy steel one. Then, get down to the basics. Are the power and data connectors clicked in all the way? I'm not kidding. I've seen a six-figure event grind to a halt because one single data cable wasn't fully seated. It's these small physical details that prevent massive digital headaches later. This right here, this is the golden rule. This is everything. Your software configuration has to be a perfect mirror of your physical wiring. The actual path you ran those Ethernet cables from one panel to the next, that is the absolute source of truth. If you lie to the software about how it's wired, the software is going to give you a scrambled image every single time. All right, so our physical build is double-checked, it's secure, everything is clicked in. Now we can finally move over to the software. Mapping is where we basically create the screen's nervous system. We are literally drawing a digital blueprint that tells the processor the exact location and the exact connection order of every single cabinet up on that wall. You know, the process is actually pretty logical when you break it down. First, you log into your software, whether it's Novastar, ColorLight, whatever. Then you define your canvas. You just tell it how many cabinets you have wide and how many you have tall. Now, here's the most important part. You trace the data path on that digital grid, making it a perfect match for how you cabled it. And always remember to map from the perspective of the front of the screen, as if you're in the audience. Finally, you just double-check your data load and send that config file to the hardware. Done. Now, that data path you're tracing, it's almost always going to be one of two types. A linear path is the simplest. You go left to right on the top row, then jump down and start again. Left to right on the second row, and so on. But to make cabling a little easier, you'll often see a serpentine or spiral path. That's where the data runs all the way to the end of a row, then snakes back in the opposite direction on the row below it. Look, neither one is better than the other, but your digital map it must match the physical one you actually built. Okay, here's a super important detail about how the processor thinks. This is called the bounding box. See, the processor doesn't just count the pixels you're actually using. It draws the biggest possible rectangle that can enclose all the cabinets on a single port, and then it calculates the pixel load for that entire area. It's basically a built-in safety net. If you try to cram too much into that box, usually around 650,000 pixels, it'll throw up a warning and stop you from overloading the system. Of course, the processor you're using really defines what you can do. It helps to think of it like this. Novastar is the ultra-reliable workhorse. It's the industry standard for corporate events, digital signs, basically anytime you need rock-solid stability above all else. ColorLight, on the other hand, that's your high-performance specialist. When you get into broadcast or virtual production and you need things like Genlock, crazy high frame rates, and perfect color, ColorLight is the tool for that job. Okay, so the screen is mapped, the image is perfect. Awesome. But to really truly deliver a jaw-dropping final product, you have to understand the science behind the spectacle. So let's dig into a few key specs that make a direct impact on what the audience actually sees and feels. First up is luminance. You'll just hear it called brightness, and it's measured in nits. Honestly, the best way to think about nits is like horsepower. For a dimly lit indoor ballroom, you only need a little bit of power. But to be seen on a bright, sunny day, you need the video screen equivalent of a supercar, with enough horsepower to punch right through that direct sunlight. It is the single most critical spec for any outdoor display, period. And this chart right here really drives that point home. An indoor screen looks amazing at maybe 500 nits, but you take that same screen outside into the sun, and it's going to look completely washed out and useless.
You need to be up around 6,500 nits, maybe even more, just to compete with the sun. The environment you're in dictates everything.
All right, so what about those mind-bending naked eye 3D effects? Why is a high frame rate so incredibly important for them? Well, it's because our brains are just incredibly sensitive to janky motion. If the frame rate is too low, the image stutters, even just a tiny bit. And that tiny stutter is all it takes for your brain to go, nope, that's fake. And boom, the fragile illusion of depth is completely shattered. Smooth, fluid motion is the only way to make that 3D effect believable.
Next up, let's talk contrast ratio. And I want you to look at this number because you'll see it on high-end spec sheets. 30,000 to 1. This number might seem a little abstract, but I promise you, it's one of the most important things for creating a truly premium-looking image.
So what is it? It's simply the difference between the brightest white the screen can make and the absolute darkest black. A high ratio like this means your blacks are actually black, not some washed-out milky gray. Think about watching a movie set in space. Without a good contrast ratio, deep space looks like a murky fog, and you lose all the detail. With a great ratio, the black is infinite, which makes every star, every planet, every spaceship just pop with incredible life and depth. So the job is done, the client's happy, the screen looks perfect. But before you can officially sign off on the project and pack up, you need to verify that it meets a few non-negotiable standards. This is your final QC, your project acceptance checklist. For any outdoor job, an IP65 rating is the absolute minimum. Here's an easy way to remember what that means. First number is for solids, like dust. The second is for liquids. So IP65 means a 6 for being totally sealed from dust and a 5 for being able to withstand jets of water. And for image quality, that 30,000 to 1 contrast ratio we just talked about, that's not a luxury. It's the guarantee that the client is actually getting the rich, detailed premium picture that they're paying for. You know, mastering screen mapping transforms you from someone who just builds a screen into someone who creates a canvas. All these technical steps we went through, they're just the foundation. Now that you understand them, the power to control every single one of those pixels is literally in your hands. So get out there, experiment, push the limits of what you think is possible. The only real question left is, what incredible visual experiences are you going to create?